Okay, so I think we were dealing with the ensemble technique. Thank you, Varun, for confirming once again. Let me just execute few code because we discussed the backing technique, we discussed the boosting technique, but we didn't implement the boosting technique. We implemented the backing technique by using your backing classifier as well as our random forest. Okay, so let me quickly make my data ready. So come till when I want, till when I want. Yeah. Till this point, it is fine. Okay. So cell run all above. Okay, awesome. My data set is ready. Yeah, okay. Now move ahead, everyone. So next classifier we're going to see is again a boosting classifier. These are so very famous boosting algorithm is your ADA boost classifier. Okay, so I'm going to say from sklearn dot ensemble once again. I'll take it and sklearn ensemble import ADA boost. Both options will be there. Your regressor as well as classifier. So depending upon your data set, you have to work accordingly. ADA boost regressor and classifier. Okay, so whatever your requirement is, use it. Done. Create an instance of the same. So I'm going to say model equals to ADA boost classifier. And see, again, we will have a parameter here known as base estimator. Can you see, everyone? Means which machine learning model you want to use it here. Please tell me. Can you see, everyone?
Yes, sir.
Right? And if you don't specify, the default will be again decision tree. Okay. If you don't specify, it is going to work, but default will be what? Again, your decision tree only. If you don't specify, it will work. No problem. Let me execute this. Okay. And let me create a model.fit on our training and testing data x underscore train. I don't know where it is picking from. Or let me use, let's see if it has been there, x train as and y underscore train. Okay. It has been done. And because see, it's accepted because default is decision tree. It is going to work without any problem. Okay. And now you can do y pred equals to model dot predict the value of your y test from the x test. So x underscore test underscore s. Okay, and let me also, I think, execute the matrices that we imported yesterday. The line, where's the line? Come on. Anyone, let me pick it here. Done, so it is all ready. And check accuracy score. Y true is y test, and y predicted is y pred. Okay, so it is giving 74.7% accuracy. Okay, but you can change it as per our requirement. Suppose again, I'm going to create a new instance. This time instance is a new algorithm. Let me use. Suppose I'm going to use naive Bayes. Okay, so I'm going to say from sklearn dot naive Bayes import Gaussian NB. Okay, and I'm going to say it M1 equals to Gaussian NB. Done. And now I can use my ADA boost classifier. So model equals to, or M2 is equal to ADA boost classifier. And within that, we have an option of base estimator and how many estimators we want, right? Right. So it is mentioned here. So I'm going to mention here, base estimator is going to be base estimator is going to be this M1. Okay, this M1, that is your Gaussian NB or naive Bayes algorithm. So I'm going to mention here M1. Okay, let me execute this. Done. And now we can train this, that we can say M2 dot fit on again same your x underscore train underscore s and your y underscore train. So my model has been trained, perfect, and now we can predict. So y pred 1 equals to M2 dot predict, and we can pass here our the value of x test underscore s. Same thing I think we have passed here. Yeah, perfect. Right, awesome. And we can check our accuracy score, how it is performing. Accuracy score Why it is true? True value is again your y test, and predicted value is y pred 1. Okay, so it is giving a awesome, a very poor accuracy. Can you see everyone? It's pathetic. Means your Gaussian NB is not working properly here. Decision tree is performing well here. Can you observe everyone here? The default word decision tree,
Yes, sir.
it is giving 74% accuracy. That's why I told you everyone, always experiment which algorithm may, because internal data set is huge, it will be very much difficult for you to analyze everything. In that case, experiment with 5-6 different machine learning models, whichever fits your requirement, use that. That will be better for you. Okay. And if I change it to the logistic regression, let's check how the impact will be there. So from sklearn dot linear model, import logistic regression, done. And now let me repeat the process. Let me get an instance of the same, suppose M3, or let me write in short, LR is equal to logistic regression. Okay. And again, I'm going to use, suppose, ADA boost classifier. So AC for ADA boost classifier, and base estimator equals to be LR. Execute. Okay, let me train the model. AC dot fit on X underscore train underscore S and your Y underscore train. Done. And let me now check Y pred 2 is equal to, because earlier we have used pred 1, I think, yeah, perfect, equals to AC dot predict, pass the value of X test underscore S. Done. And let me check the accuracy. Accuracy score of true value is your Y test, and predicted value is Y pred 2. Done. So it's better, way better than what we were getting with the naive phase. Naive was giving only 30%, and it is giving your logistic regression is giving you 77.5. And what decision tree is giving you, I think we observed that 74.7. Although every machine learning model can be tuned by changing their hyperparameters. Okay, but you get an average idea how well they are performing. Okay, so this is one in which you can put an estimator, and similar to random forest. In random forest, what bagging algorithm in which your base estimator was fixed. Always decision tree. You cannot change that. Similarly, here we have an algorithm very much similar to that, known as, but this is a boosting algorithm known as gradient boosting algorithm, in which your base estimator is fixed, always decision tree. Once again, okay, so very much similar to random forest. Random forest is a bagging algorithm in which your base estimate is always decision tree. Similarly, gradient boosting is your boosting algorithm, where always your base estimator is fixed, again decision tree. Okay, so how can we use that? From sklearn, same dot ensemble, import gradient boosting classifier and regressor. Both you can use as per your requirement, right? And same way, now you know how to work with it. Okay, let me directly copy the step. It will save our time. 1, 2, 3, 1, 2, 3, 4, 5. Okay, Control C. Yeah, and instead of AC, let me make it GB. And here I will make Shan gradient boosting classifier. And here you will not see the option of base estimator. Can you see everyone? It is not there, right? So I can execute this. I can make GB.fit. Okay, and I can do Y pred 3 is equal to GB dot predict and accuracy score Y pred 3. Okay, it is giving the best accuracy. Can you see 80.89? Awesome. This is how you experiment. Okay, more than 10 algorithms we have seen so far. More than 10. Okay, if we start from where we started from, remember we started with our, I think, KNN. Then with the KNN, after the KNN, I think we did naive base.
New base.
Okay, after the naive base, I think we did decision tree. After
Yes, sir.
decision tree, linear regression.
The
Okay, after linear regression, we did logistic regression.
logistic
Okay,
regression.
and after that, we can say bagging classifier. Okay, then we did our bagging
Random
classifier.
forest in bagging.
Yeah, random forest especially. Then we did ADA boost. Okay, and then we did last one is your gradient boosting. And in fact, in these two, especially you can play the way you want. Change the algorithm, check the result. Change the algorithm, change the result. Change their hyperparameter, see the performance improves or not. Okay, so almost 1, 2, 3, 4, 5, 6, 7, 8, 9 algorithms we have seen so far, right? Now let me come tell you very, very interesting technique that is actually very good, right? So whatever we have been doing so far, let me open the paint. Okay, what we normally did so far, suppose somebody gave me some data. Okay, somebody gave me some data. This is my data, entire data for machine learning model. So what we did, we divided our data into two parts like this, right? One became your training data, okay, and one became your test data. Train and test, right? And what we did, on the basis of this trained data, we trained our machine learning model, right? On the basis of this trained data, we trained our machine learning model. And once my model is trained properly, once my model is trained, then we passed that data. Example, this is my machine learning model in between somewhere. Okay, so what we pass to our machine learning model, we pass this trained data to train it, right? Once my model is trained, I say my model is trained, we pass our test data, okay, to my machine learning model like this from here to check how is the performance. Okay, so what we in fact did, we hold out some data for validation later on to check how my model is performing. Okay, this is what we did. We divided our data into two parts, training and testing. Okay, this is the phase available. This is one phase, means you put some data here, you put some data here. Okay, so this data you kept separate somewhere so that later on I can check how my model is performing on the unseen data. This kind of method that you check for checking for your model is known as hold out validation method. Okay, it's known as hold out validation method. Okay, because you hold out some data, okay, with you like this. This data set you hold out with this. This is known as hold out validation method. It's fine, but not a very, very, very good way of checking how my model is performing. Okay, so there is a gold standard available for the same gold standard, which is better than this method that you are seeing right now. What is that? Okay, that is known as actually your k-fold cross validation technique. Okay, k-fold cross validation technique. Okay, in which what we do, suppose your boss gave you some data. Okay, your boss gave you some data. So what you will do, you will take that data. Okay, you pick some data. This data is with you. Okay, and normally what happens, understand everyone, this test data that you are seeing right now, okay, it will be kept with your data scientist only. You are, if you are a machine learning engineer, so they will give you one data only. They'll say, please take this data, and after taking this data, do whatever you want to do. I will check later on with my unseen data. So normally they keep some piece of data with them. So whatever data they give you, suppose this is the data which is available here. Okay, this is your data, entire data which is available. Okay, so what happens? This is known as k-fold. Okay, so suppose I mentioned k-fold. I means the fold should be suppose 5. Okay, so I mentioned 5-fold cross validation. What it does, it divides your entire data set into 5 folds or 5 groups like this. One group, second group, third group, fourth group, and fifth group. If you mention 5, you can mention 10, 15. 5 and 10 are very much recommended. So 5, 10 you mention here. Okay, so suppose you have 100 data points overall in your data set, 100. Okay, and you mentioned 5 folds should be there. So in every fold, you will have 20 data points. Everywhere 20 total, because total is 100. So 20 will be here, 20 will be here, 20 will be here, and 20 will be here, right? But it's not that this 20 will be in sequence. No, it is not the case. Okay, 20 out of the 100, any 20 random points will be picked. Okay, and they will be placed in the first fold. Okay, but they will not put back. So now for the second fold, 80 will be remaining because 20 has been picked from the 100, but those are picked in randomly. So one may be sequence number 1, one may be sequence number 5, one may be 17, one may be 18. Those way 20 points have been picked here. Now, out of those 80 points, remaining 80 points, next 20 random points will be picked. Again, next 20 random points will be picked. Again, next random 20 points will be picked. Again, next 20 points will be picked. This is how you will create your fold. Now, what we will do, understand. So there are 5 folds: 1, 2, 3, 4, 5. Now your machine learning model will be trained on in first iteration. It will be trained on these 4 example, these 4 folds or these 4 groups. Okay, 1, 2, 3, 4. It will not be trained on this. So it will be trained on these 80 points, and these 20 points will be not be trained. So these 20 points will be used to validate the result, to check the result, how the model is performing. So this will act as a training data, 1, 2, 3, 4, and it will act as a test data in first iteration. Okay, in first iteration, you get some result saved somewhere. Suppose result is accuracy is 80%. Now what will happen, everyone? You'll move ahead. This time, now any other 4 folds will be taken. Suppose these folds are 1, this one is picked, this one is picked, this one is picked, and this one is picked. So 4 are taken. Now again 80 points are picked for the training. Okay, again 80 points are picked for training, but different 80. This 20, this 20, this 20, and this 20. Now this will act as what your test data. This will act as your test data. So your model will be trained on these 80 points and tested on these 20 points. Okay, so again you will get some result. Okay, for this fold, suppose it is 76%. Now it will repeat the process. Again, same will happen now. Again, so this has been used as a test data. This has been used as a test data. Now what will happen again? And another fold. This will be picked. This will be picked. This will be picked. Okay. Or sorry, let it be, because these two have been taken as test data. Suppose this will not be picked. Okay. This will not be picked, and this will be, suppose this will be picked, and this will be picked. Okay. So 4 for the training. 1, 2, 3, and 4, and the middle one, this one for the testing. So data set will be trained on this, and this. Okay, and tested on the basis of this. So you get some accuracy. Suppose this accuracy is this. Suppose 89%. Right. Again, same process will repeat again. So now this time you will take this one, this one. Sorry, this one, this one, this one. Okay, 1, 2, 3, and 4. Your data set will be, means your model will be trained on 1, 2, 3, 4. This middle one will be kept for the testing purpose. Trained on the 80 points, this one will be used for the testing purpose. Now again you will get some result for the same. Suppose 75%. Okay. Now last, your model will be trained on this, and tested on this. So again you will get some results. Suppose 70%. This is what it will give you. Okay. Now from this, you can take a mean or average. What should be my average accuracy? So basically, we use this k-fold cross validation just to ensure that what can be, actually, this is how we use, what can be the average accuracy achievable by this data set, by this machine learning model. Means whatever data set is given to me on this particular machine learning model, whatever I am using, suppose KNN or machine or KNN or decision tree or naive Bayes on this particular data set with this particular model, what can be average accuracy achieved? So you should try always to achieve at least that minimum accuracy that are receiving by this average thing is which is available here. Okay, because it is tested almost everything of your data point. What is the possibility? That's why it is giving you average. Everything has been checked on the basis of training and testing. Okay, so this achieved. Now done. Okay, this should be the average accuracy which is achievable. Now, when you are training your model, you should ensure that your minimum accuracy should be at least equal to the accuracy, average accuracy given by this k-fold cross validation technique. That's why it acts as a gold standard. It acts as a gold standard for you. Okay, so compare with it, and if it is giving you 75%, ensure that your model that you are training should be at least 75% or above, not below that. If it is below that, do some modification and ready for the preparation. Clear, everyone? Please tell me, what is the purpose of k-fold cross validation?
Yes, sir.
Okay, it should be clear. Okay, so how do we do that? Very, very simple process. There is nothing complicated here. Suppose I come to again. Okay, Varun, fine. Okay, I come here and mention here from sklearn dot model selection import cross-val score like this, right? Come here, mention cross-val score, okay, and read the argument it needs. It needs an estimator, right? which machine learning model you want to test. Okay, which machine learning model you want to test, and you have to pass your x and y value. So which machine learning model? Suppose, let me pick any one. Let's say, let me create an instance, no problem. Again, let me check gradient boosting. So I'm going to say GBN is equal to gradient boosting classifier. I create instance of the same. So first thing I have to mention here, control come here, your estimator. So estimator should be GBN. Okay, now it needs your x value. So x value is, let's say, extreme. Scale, let it be scale, no matter. Okay, y value should be y train. Okay, and move ahead. And scoring means what is the performance metric. If you don't specify, the default is your accuracy. If you don't specify, the default is your accuracy. And second one, this is important, your cv means how many folds you want. Okay, how many folds you want. By default is 5. The default is 5. Okay, so these are the two parameters like I mentioned here. Scoring. Okay, so scoring by default is accuracy. You can mention here accuracy. Okay, and default is there only, and cv value is by default 5, so I can mention 5. Okay, so let me execute this. So see, I'm because I put the 5 fold, I'm getting 5x. Can you observe, everyone?
Yes, sir.
Right, for every fold we are getting some accuracy, but what we are concerned, we are not concerned about every fold, we are concerned about the mean. So what I can do, I can again copy this. Remember, in accuracy, what you will mention, in accuracy, you will mention a metric that you want to use. Okay, so come here and you can mention dot, because it's an array, right? It's an array. So array, we can apply the method mean method. Mean. So mean accuracy achievable is 82.93. So at least work on your machine learning model, which is giving lesser accuracy. So it is giving, using the gradient descent, you should achieve how much? 82.93. Okay. So do something, do some feature engineering or something, whatever you want to do, at least achieve this much amount of accuracy. Getting the point, everyone?
Yes, sir.
Okay. Now again, very, very interesting thing. Okay. That is your hyperparameter tuning. Hyperparameter tuning. Okay. I'm taking some hyperparameter tuning. Okay. And what is that? Suppose I'm importing a machine learning model from a decision tree, let's say sklearn dot tree import decision tree classifier. Okay, I just import that. Okay, let me create an instance of the same. dt is equal to decision tree classifier. Okay, it has several hyperparameters, everyone, inside that. Okay, and few very important hyperparameters are your example, your depths. Okay, your maximum depth, which is available here, right? And with the help of this, we saw that how can we improve the reduce the overfitting. Okay, an example, min sample split. Okay, and you want to suppose the minimum sample leave. 3 parameters are there, but you want to check on 1 how it will perform, and 2 how it will perform, how 3 how it will perform. We can do that with the help of for loop. Okay, by putting max depth in one list, 1 2 3 4 5 6, and iterate over this. For the 1, what result I will get, for 2 what I will result get. Similarly, min sample split I can take, I can verify 2 how it will do, 3 I will do, 4 I will do, but it will take your very, very strong, means strong programming skills. If not programming skill, at least it will be little complex to write. Okay, and to decide the better. For that purpose, actually, we directly have availability of hyperparameter tuning using grid search. There is a method available, grid search cv. Okay, that grid search cv will help us out in achieving that requirement. Let me choose first of all whichever parameter I want to tune. So suppose these 3 parameters I will tune. Just copy those. Okay, come here, paste them here, and let me execute this. No, and now let me import that hyperparameter tuning parameter. So I'm going to mention from sklearn dot model selection dot model selection import grid search cv. Okay, this one that we need. Okay, and we have to decide which parameter. So I want to change the depth parameter, so I'm creating a variable depth. okay, in which I'm putting the value that I want to test. Okay, on this, what will the result, on this, what will be the results? I'm putting some value. Suppose depth, I'm putting 1, 2, 3, 4, 5. So I want to check max step to be 1, max step to be 2, max step to be 3, max step to be 4, max step to be 5. Similarly, I'm going to put here minimum sample split. So I'm going to say splits equals to whatever split 2 is there. Let me mention 2, 3, I want to test, 4, I want to test, 5, I want to test, how it will perform. Okay. Again, next, suppose sample leaf. Okay. Whatever is sample leaf. So leaf. Okay. Equals to, again, I put suppose 1, 2, 3, 4, 5. I want to test this. Okay. Then I would do what? I will create a dictionary out of the same known as parameter grid. So any name you can give, it's your choice. So I'm going to say P grid, parameter grid. Okay. So what I will mention here, okay, this is your parameter, right? For which value you want to check it. So I'm going to pick it, make it a key like this, max step. And within the colon, I put the values that I want to pass. What is that depth? So I mention here depth like this. Okay, or you can directly pass your list here without even creating this variable depth separately, but actually it looks systematic. Whenever you want to make the changes, directly you can do. Otherwise, directly you can copy from here and you can paste it here without using depth split and leave. Okay, second parameter, let me pick it up, is your min sample split. Just name, these names should be proper, everyone. Remember, these names should be proper. Otherwise, this name can be anything, doesn't matter. These names should be proper because these are hyperparameters. Just pick it up. I pick it from the model. Remember, I just copied from there and pasted here for the same purpose because it's difficult to remember everything correctly. Then I put a colon and then what? Splits. Third one, again, min sample leaf. Let me just copy this once again. Okay. And let me put it here. Sorry, colon, this time leaf. So my parameter grid is ready. Now we'll pass this parameter grid to my grid search. So I'm going to say grid search CV. Okay. It needs what? First of all, an estimator. If you go there, first is estimator. Estimator is what? DT, decision tree that you have created. Okay. So DT. Okay. Then what it needs? It needs a parameter grid. So what is the parameter grid that you've created? There is an optional parameter known as, sorry, there is a parameter known as parameter grid. Param grid. Okay. This is equal to this grid. P grid. So P grid. Okay, what on the basis of what you want to test, which parameter is better? Scoring. Scoring equals to I want again accuracy, suppose. Okay, and how many k-fold cross validation you want? Okay, so CV, and suppose I want to use all the processors, so we have an option available known as n underscore jobs. I want all the processors, so -1 I'm mentioning, and k-fold cross validation. Suppose I want to be 5. Let me put it 5. Okay, these are the parameters. This is your machine learning model. This is the parameter grid that you have created. Okay, this is parameters. I just passed it here. This is the scoring on the basis of which you want to decide, and this is number of jobs, means I want to use all the processes, and how many folds I want, that we just discussed right now. Okay, and let me assign a variable to this. Suppose this is nothing but your GS. Okay, so what it is going to do, understand everyone, very important. Okay, it will check your machine learning model for every possible combination of these parameters. Okay, every possible combination. 1, depth is 1, split is 2, leaf is 1. What is the performance? Depth is 1, leaf is 3, leaf is 1. What is the performance? Depth is 1, leaf is 4, leaf is 1. What is the performance? So every possible combination it is going to try, and whichever possible combination is giving you maximum accuracy, it will tell you that which is the best possible combination among these only. Okay, you can put it as many as you want, so it will pick from whatever you have put. So every possible combination it will test inside, so you don't have to write a loop or something. Automatically it's trying to test the best possible combination as per accuracy, which is giving you maximum accuracy, right? So next parameter, let me fit. So gs dot fit. Okay, on which data? My x train. So x underscore train underscore s and y underscore train. Okay, let me execute this. It may take some time. Let's wait. Load it very fast. Awesome. Let me check. Okay, so how will I check? GS, let's see what is the best result we are getting. GS dot best score. 82.65. As per this combination, decision tree is giving you 82.65% accuracy. This is the best result that has been obtained by your decision tree on the basis of which parameter, among which of these it has been selected. So let me check that. Go here and this time put gs dot best parameters. Best again parameters. Okay, so these are the parameters. Depth should be 4, sample leaf should be 5, and minimum sample split should be 2. This is the best combination it is giving. Okay, among the parameters that you pass, this possible combination is giving you best result. So after training your model even, okay, you can improve and you can test for the accuracy by using this hyperparameter tuning, how well it is performing. Okay, and remember earlier we tested our decision tree classifier. I think where was that? I checked it somewhere. I don't remember where it is, but we did somewhere. Random forest. I think we did. Boost. No, before this, I think I did. Not sure. The same data set we did somewhere, but I'm not finding. But understand your accuracy has been improved. Okay, so you can check. Okay, what is the accuracy I can achieve? You can further tune this. You can change these parameters. You can experiment them. Okay, and you can't memorize this. Okay, this is the every hyperparameter of every machine learning model is impossible. I repeat, it is impossible. So always go to the Google, type your machine learning model. Just type hyperparameter of this. Okay, automatically they will give you. Okay, these are the hyperparameters. Okay, and what are the possible values? So automatically just create your grid and experiment. This is the way to learn. It is impossible to remember all the things. It's impossible, right? You cannot remember all the hyperparameters of so many models. Every model may have 10 to 15 hyperparameters. You'll get crazy that way. It's not possible to remember. Just whatever model you are using, just remember I will try to do hyperparameter tuning. If your accuracy is coming 80%, try to increase it to 90%, 95%. Try to do how well you will do using hyperparameter tuning. Even feature engineering may increase your accuracy. That's a different issue. But hyperparameter tuning will certainly help you out. What are the best possibility? Okay. And what is the best possible model that suppose I want to check? So directly I can pick it from a GS dot best estimator should be their option. Best estimator. Okay. So it will tell you, see directly it is coming. Now you can use this and fit your machine learning model directly. It is coming. Max step is 4, min sample leaf is this. Automatically it is coming. So you can pick it up and directly tune your model as per your requirement. Control C and you can use this, sorry, Control Z, pick it up. Okay, you can say model M equals to this, done, and fit your model. So model M dot fit on extreme underscore S and Y underscore tree, like this. I hope it makes sense, everyone. Clear how much powerful it can be. So you don't have to do the rigorous work. It can help you out. Awesome tool this is. Awesome tool this is. Tell me, everyone. Fine. Everybody's
Fine,
silent.
sir.
Okay, fine. Varun, is it okay? Varun is there, I guess. Yeah. Swati ma'am, Amrita ma'am, fine. Okay, good. Very good, right? Now see everyone. Okay, so this can help you out in choosing the desired parameters. Whatever parameters will be helpful for you. Okay, so two very important things we discussed so far were k-fold cross validation. Second is hyperparameter tuning. Now come to third, very important. Okay. Let me read my Titanic data. I think we have a Titanic data set itself. Let me check what is the DF right now. Yeah, it is. Let me check the shape of the same. Let me start away read. Df is equal to pd dot read underscore csv Titanic dot csv, right? And let me come here and df dot head. Fine. And let me do one thing. Let me pick any particular column. This is my output column. So according to that, let me decide, check how many survived columns are there. Sorry, how many persons survived and how many don't survive. So survived dot value underscore counts. Okay, so 542 unsurvived and one survived. It's sorry, 545 doesn't survive and 342 survive. Okay, so this data is balanced or unbalanced as per you, everyone. Remember, whenever we talk about the balanced data, then how doesn't matter how many classes are there. In every classes, they should have same values available. That is known as your balanced data. Okay, that data which is having equal number of data points for every class is known as your balanced data. But in practical scenario, most of the time your data will be imbalanced data. Most of the time, okay, your data will be imbalanced data. What do you mean by that? Let me come again to the pane and I'll explain you that. Suppose I come here, uh, again pane. Yeah, okay. Suppose you are solving a problem of credit card defaulters. The problem is credit card defaulters. So can you tell me, everyone, if you receive this data set? So we will have two kind of people. One people who will be defaulters, okay, and second category of people who will be non-defaulter. Defaulters means who doesn't pay the bills and everything, right? So these are your defaulters, okay, and these will be non-defaulters, means non-defaulters. So if you people can tell me, everyone, what do you think? In real time, this data set will be balanced, means equal number of person defaulters, equal number of non-defaulters,
No, sir, it will not
right?
be.
Yeah, it will not be. So what will be more, defaulters or non-defaulters? Defaulters are always
Defaulters
rare.
will be more.
No, defaulters are always rare. Defaulters are, what do you mean by defaulter? Defaulters are those who doesn't pay the bill regularly. And actually, in real time scenario, those such people are very less. Okay,
Okay.
those are very less. Most of the people pay bill everything on the time. Okay. Similarly, if you receive a COVID data set, understand, everyone. Again, you receive a COVID data set. What happened? Okay, you receive a COVID data set. Okay, in that COVID data set, suppose 1,000 people went for testing. 1,000 people went for the testing. So what do you think? Some people tested positive, some people tested negative. What do you think? What will be the ratio? Will it be balanced or imbalanced this time again?
Imbalance again.
Again, imbalanced, right? So in real-time scenario, your data set will be imbalanced. But unfortunately, imbalanced data doesn't give you that much good performance. So what we should do? Okay, so how to deal with that imbalance problem? So two ways are there. Let me show you that. Okay. So suppose I have two classes. One is your two classes are there, majority class, and second one is minority class. Minority means which has less samples. Okay. So suppose in majority class you have 1,000 samples. In minority class you have only 100 samples. So how can we deal with the balance problem? How can we balance them? Okay. So there are two ways again. One known as undersampling. Okay. And second method is known as oversampling. Okay, one is undersampling, second one is oversampling. Undersampling, what we did, we reduce the data points of the majority class so that they become the equal to the minority class. Getting the point what I'm saying, everyone? Undersampling means we reduce the data points of the majority class so that they become the equal to the data points of minority class. But it is a very, very bad technique, right or wrong? You're losing important data points, right? So what will happen in the undersampling, if we talk about, it will become like this. Your majority is 100 as well as your minority is equal to 100. So you reduce your majority data points. Okay. No, actually it cannot solve that. Okay, it can just, no, Stratify cannot solve your this problem, Varun. It can just help you out in prediction. Means same kind of prediction is there, but still data points are less. Then of course your performance will impact for sure. It cannot solve that issue. Stratify. Although it can help you out, means in the training data as well in the testing data, you have the same ratio maintained. Whatever is the ratio in the original data set, same you are maintaining in the training and the testing. That is the basically purpose of stratify sampling, right? Same ratio you are maintaining. Still data is still imbalanced. Okay, just to get the same idea from what training data is seeing, the same kind of data should be seen available in the test data. For that purpose, actually, we would stratify. Okay, Varun. So it cannot solve your imbalance problem. Yeah. Okay. So this what we did. We reduced the majority class. We reduce the data points of majority class. This is nothing but your minor undersampling. Okay. Of course, you can see what is the oversampling. Now what we will do, we will increase the samples of minority class this time. We will increase the samples of minority class. Okay. In earlier case, we reduce the samples of majority class. Now we will increase the samples of minority class so that they become equal to the majority class. But you will say, sir, how it will do? There are two ways. Okay. Again, there are two ways further. Okay. One is known as your random oversampling. Okay. And second one is known as your synthetic minority oversampling technique. Synthetic minority over sampling technique. Okay, two techniques are there. Which one is preferred? Somebody asked you. Synthetic is preferred. Why? The reason I'll tell you. What is the random oversampling? Okay, so of course, in random oversampling, so you have how many points? 100 data points. So it will pick one random point from the minority class and add it to your data point. So now it will become 100 plus 1. Okay, so earlier you have only in minority class 100 points. Okay, so pick one random data point from minority class, put it here. So it become now 101. Again, pick one random sample from the minority class, make it 102. Okay, so same data point which are available in the minority class, you are picking them and you are adding to your data set. Same you are adding again, one more, again one more, again one more, again one more. So your data points are coming from where? From only minority class. Again, same data points which are already there. Same data points you are copying again and again, again and again, again and again. This is nothing but your random oversampling. Clear, everyone? You will pick data points from a minority class only to increase the number of samples. That's it. And those points you will pick randomly only. Any one. So it may be possible one data point is appearing 100 times, 200 times, 300 times. You never know. Okay. So what is the possibility here? Because same data points are repeating there. So there is a chances of overfitting as well. Because same data points are repeating again and again, again and again, again and again. Clear, everyone? What is random oversampling?
Yes, sir.
Okay, now what is that? Synthetic minority oversampling. Instead of that, instead of picking the data from minority samples, actually synthetic samples will be created. Okay, synthetic samples. I repeat once again. Synthetic samples means the samples which will not be available in the original minority class. Okay, so synthetic, that means artificial minority samples will be created. Okay, and this particular technique, that synthetic minority oversampling, is very, very famous technique known as SMOTE technique. SMOTE, very popularly used, very, very popularly used. So what they do, they generate a synthetic minority oversampling. But how they do? Now let's come to that. Let me again come here. Suppose here we have y-axis and here we have x-axis. Okay, and here the data points is suppose x2. Okay, and here we have x1. Okay, so some data points are lying here of majority class like this. Oh, sorry. Let me break it here one and let me copy this. I can copy, I think. Control C like this and drag them here if I can. Oh. Well, let me do one thing. It is very difficult to draw. Come on, let me do manually, right? So we have some samples here. Several samples here. Okay, these are majority class. right? And we have very few samples here of minority class like this. Right? So how minority oversampling works, synthetic minority oversampling does, okay? It pick a data point example, it picked a data point, okay? And internally it choose one parameter, is k nearest neighbor, okay? K nearest neighbor, okay? So suppose it decide k nearest neighbor will be 2. So it will find, okay, who are my 2 nearest neighbors? Suppose this minority sample. So we're talking about whatever will happen in the minority class, it will happen. So it's a handout that, okay, 2 nearest neighbors is this and this. So it will connect this point to this point to this using a line. Okay. Now your new samples will be generated along this line. Suppose you want to generate one sample. So one sample will be here. Two sample, second sample will be here. Third sample will be here. Fourth sample will be here. Okay. And because they are in the minority zone only, so these all will belong to the minority class only. Similarly, some new data point will be generated along this line. Along this same line, which is joining these two nearest neighbors. Okay. But you will say that how it will automatically generate. Actually, what it does, so it computes the distance between suppose this point and this point. Okay. And the distance came around, suppose D. The distance is D. Okay. And suppose this original point that is here is having represented by a point X, having some coordinates X and Y. Okay. I'm not mentioning that. Suppose X is there. So what it does to this X, actually, they add some value. What is that value? X plus, okay, a random number it generates. A random number it generates between 0 and 1. Okay, internally it will generate a random number between 0 and 1. Okay, and multiply this random number with the distance between these 2 points. These 2 points. Suppose that is T. Okay, and whatever the coordinates now I will get after taking the coordinates of my X data point. Okay, and adding to it what the distance, whatever the distance, multiply by a random number between 0 and 1, you will get one new synthetic sample coordinates. This is my new sample. Okay, this is my new sample. This is corresponding x1 value, and this is corresponding x2 value. This will become my new synthetic sample. Again, next sample is generated. Again, it will generate a new random a random number, a random number between 0 and 1 again. Okay, so again you will get a second sample. Again you will get a sample. So this is how you get your new synthetic sample. These sample actually not exist in your database, okay, or your data point. These are being generated automatically by the synthetic minority oversampling technique. Automatically it will be generated. And how it will be generated? Simple. It will pick, okay, what is the k nearest neighbor. It will internally choose some k, and it will find out, okay, what are my nearest neighbors. It will join your one point with those nearest points, and along those lines your new samples will be generated. Okay, I just like mentioned, it may be here, it may be here, it may be here, anywhere it can be, depending upon how many samples you want to generate. How they generate it, this is the formula, how it is going to generate. Clear, everyone?
But sir, if we generate this like this way, what this random number will have an effect on the real data? Like,
No, it is not
will
going
that?
to, original data point will remain the way they are. Okay, only new synthetic samples are generated. Original will remain the way they are. They will not be touched anymore. This
Okay.
additional point
And
you are adding.
sir, I got that.
Mhm.
And this random data which will be generated.
Mhm.
So the generation of this random number will be in normalized way or in Gaussian way. Like out of 10 numbers, will it be like that that most of
Remember,
the numbers will be
remember where it is, what its value is lying, 0 and 1, and which thing lies between 0 and 1. You uniform norm,
normalized,
your uniform
uniform,
distribution, your
uniform?
uniform
Sorry. Yeah.
distribution, right? So it will be coming from uniform distribution.
Okay.
Okay, because your, remember, normal distribution can have positive value and can be negative value. It can't it be generated by mean values like we do in the missing data case. It depends. It may be giving that, but for the mean value you will get only one sample, right, Varun?
Yes, sir.
No, actually,
Yes, sir.
how? No, no. Varun is asking. Actually, Varun is asking a
Okay.
question. Can't it generated by a missing value, by mean value? Okay, so mean value will give you only one sample, right? Right. So samples will be limited. Samples will be limited. That's the only issue. But yeah, good idea. At least you think about it. You think about it. That's a good idea. But yeah, but for that case, your samples will be limited. Okay, so doesn't matter if you are an MTech student or a PhD student, you can try your own sampling technique, which can be better than what SMOTE is doing. Maybe possible, right? And people are doing research. People are doing research, but SMOTE is very popular. People may have produced several research papers as well, which I don't know are not that much popular. SMOTE is very much popular, but you can think about it. Okay, I can develop my own sampling technique, which can be better than the other sampling technique which are existing. Okay, so how can we do that? Let me come here again now. Implementation part. Okay, about the same. So let me do one thing. A df survived, it is this. Let me pick x. X is what? Suppose x is equal to df dot drop survived column. Okay, and axis is equal to 1, and your y is nothing but df of survived. Fine, let it be like this. Okay, so now let me import our sampling. So I'm gonna say from sklearn dot, so not sklearn, it is from imbalanced library, imblearn. Come on, take it. Not taking, don't you? Imblearn dot combine import on ticket. It's fine. Import SMOTE to Mac. Let me check. SMOTE to Mac. Not no module node IMB learn. Okay, it has been changed or something. What happened? It should work. IMB learn dot combine. Everything is fine. This is the library. Let me just check again. No module found IMB learn. No issue. Where my model go? Yeah. From IMB learn dot combine import SMOTE to Mac. Everything is fine. What happened with this?
Sir, did we imported the IMB learn library before?
Normally it works directly. Let me check. It works directly normally, but let me check from import IMB learn. No, it's same. See, uh, let me see an example. That is fine. See, same library is this. We copy. I don't think so. There is any difference. From IMB learn dot combine import SMOTE to Mac. I think everything is fine. SMEM IMBLEARN dot combine. See, exactly same thing. Whatever is mentioned in the official documentation. What is the issue? Let me pick something else. They made some changes, or why it is not working? Let me just write here, because everything is same. Same command is there. It is not even recognizing. Are they have done some installation purpose or something? Just a second. Come here. IMB learn module not found. Let me try this. Or let me do one thing. Pip. Let me try from the pip. Py IMB. They have made it installation mandatory. Earlier it was not there. Let me check. Earlier, without installation, we could have worked. They have made it installation mandatory. Otherwise, like sklearn, we have not installed now. It is directly supporting. Come on, come on. Warning is coming. Uninstalling. No, it's not doing that. Let me check. It is working or not. No, still not working. Come on. So let me use some other method. Let me do one thing. Anaconda. Conda. Not available from current channel. No, it is not saying that. Not finding. Let me try any other way. Because whatever ways are mentioned, it's not doing that. IMB, learn. Let me try to see something else. Meanwhile, it is doing. Here, some options are given. No, 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 no. No, where it is mentioned here. What happened? Done? Okay, very good. Right. I think it is done. Okay. The current user does not have right permission to the random. No issue. That problem can be solved. That's not a problem. Anaconda. Prompt. Right and click, run as administrator. Come on. Now it should be done. I think tomorrow we'll have a last class, everyone, right? Am I audible?
Yes, sir.
Okay, fine. Actually, it didn't work earlier because I was running from a normal user. I have to work as an admin. I think you people must have received your certificates.
Yes, sir, we have.
Oh, okay, okay, great. Now please do, please do. Why? Yeah, done, 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 done. Very good, awesome. Now let me come back. Now let me try to do. Yeah, now done. Perfect. So now it has been done. Now let me come here, and now it has been imported. Can you see everyone now? It has been done. Okay. So
Yes, sir.
now, yeah, let me remove this. And now let me mention whatever you mentioned. Suppose what we want. Let me create an instance of the same. So what is the name? SMOTE. Come on, take it. Tomac. Okay. And there are several parameters. One is the strategy. Actually, there is one thing known as sampling strategy. Right now it is okay, but there are several parameters available. Automatically it will pick up. So let me just try first of all with a random. There is a parameter also known as random state here. According to that, actually it may pick a different number of samples according to that. So let me pick it, for example, 45 for now, and smart tomic is fine. And let me. It will give me two things. Oh, so no, I'm creating an object right now only. So SMK. Suppose SMK. Equal to smart tomac random state 45. Done. And now let me use smk dot fit, and within that let me pass fit underscore. Yeah, sorry, fit underscore should be there. Resample, yes, because we want to resample on the basis of x and y. So x comma y, and it will give me two parameters. So x underscore resample, suppose, and y underscore resample. Okay, so I just imported this. Okay, create an object of the same, and I'm just resampling. Okay, just using the method fit underscore resample. So it will resample that. Let me come here. Okay, what error it is showing? Again, let me verify. Could not convert string to the float. Mr. Owen Harris value error. Why it is showing the value error? No issue. Let me do this thing before using this. Before doing that, PD. Okay, let me drop that column. Oh, survived, and as well as one more column. The column name is, I think, name column, if I'm correct. I don't want this. Let me execute and let me check. First of all, x dot head. Still a text value is there, fine. So let me change it to x is equal to pd dot get underscore dummies. I'm going to pass here my x directly. And I'm going to mention drop underscore first equals to true. Okay, now let me use it. X is fine, Y is fine. Now let me execute. Yeah, done. Let me check now. Y underscore res dot value underscore counts. Can you check everyone? What has become there?
Yes, sir.
Okay, so both classes have become now your equal class, balanced class that we want. Actually, this number will change according to the random state that we will pass here. Now, suppose I mention here 42, so you'll get a different number here. Suppose I use this, I execute this, I execute this. This number will change actually. Can you see now? So on the random state parameter, this value will change on the basis of random state that you are going to mention here. Okay, and there is also one more parameter. Suppose you don't want equal number of samples. So again, we have a sampling strategy here, actually a parameter known as sampling strategy. Okay, and different options are there that you can pick it up, and it's mentioned here. If you go here, what can be the different sampling strategy? Go back here. Float is there, string is there, dict is there, or default is auto. We did with the auto purpose. So you can read out what is happening with the, when you put a strings, when you put minority, what will happen? Resample only the minority class, not minority, resample all the classes, but the minority class. Not majority, resample all the classes, but the majority class. all, resample all the classes. So depending upon your parameter, you may put different parameters, right? So what I'm going to do here, I am going to put this float. Float thing is what? Float actually gives you a ratio. When it is a parameter known as a float. So float tells you, okay, so you have a, suppose a majority class and a minority class. So what ratio you want between them? Okay, how much should be the minority class of your majority class? That's what you want to mention. So floating point number you can mention here. Suppose I mention here 0.8. Okay, so 0.8 means 80% of the majority class. 80% of the majority class. Let me execute this. Okay, again execute this. Okay, can you check everyone? This is not complete. Can you see the difference now?
Yes, sir.
Okay, so this is the one, means you how much you want, how much percentage you want out of the your minority class should be how much percentage of your majority class. You just mentioned 0.8 means 80%. If you want complete, mention one back again, execute, right? Same 501, 503. So default auto it will take automatically. Now you can use it because your X is ready, your Y is ready. You can fit your machine learning model as per your requirement now, right? They are ready to be used. You can check. Example, come here, check your X underscore res. See, it is reading how many points? 1006 points. Can you observe everyone? Looks like the same, right? Can you observe? Right? Similarly, your
Yes, sir.
Y-res. So you can use it for now, further as per your requirement. Your Y-res, again, same 010101 survive. Same rows. So now your data set is with you. Whatever you want to do, you can do that. Okay. So I'm ending for the day, everyone. Tomorrow will be our last class. And I think I tried my best. I don't know how good I was, but I tried my best to deliver whatever I know. And in shorter, actually time was very less. That is the main issue. We promised for the 6 weeks, but I think it lingered for more than 6 weeks, if I'm correct. But I didn't want to skip anything. That was the main objective of mine. Means everything should be covered, not in hurry. That formality has to be done. That was my main objective actually. I don't know how you people find it, but I tried my best here, honestly speaking.
Yes, sir. It was a really good session. Like the whole, all the sessions, and we all got to learn a lot of things. At
I
least
just,
those who attended classes regularly.
yeah, that matters. That matters a lot. That matters a lot. Actually, there is a batch going on just before you people, right? That batch is very sincere, very sincere. There are various people. So all the time I saw 90 plus. All the time. It has been more than a month. All the time 90 and very sincere.
The one which started after us or before
After
us?
you, after you, after you.
Oh,
Those are very sincere. Means very much like you, Varun, and you people, and even Amrita ma'am comes regularly here, and Swati ma'am is also there who comes regularly. Okay, these two people come regularly. There is one more person who is not here, ASP Gautam. He also comes regularly. Otherwise, very few people come regularly. Okay, those have done very well. And prior to that, there is actually a batch before you was there. Let me just stop the recording. It will again become